Okay, so today what we're going to do is we're going to draw some truth tables for propositions, and we're going to also learn some classifications of statements, right? So we're starting with our truth tables for propositions. We did truth tables to define the 5 logical operators. Now we're going to do it for some propositions. Okay, so our first proposition is going to be A, or if A or not B, then B. Now, I'm going to be completely honest with you. Truth tables are ugly. There's no way around it. Maybe if you're using graph paper, they look a little nice because everything's in a grid, but these things are ugly. You just kind of have to deal with it. And just like we did for to define our logical operators when we had two statements, so in this case A and B, we have to go through every case and assign every combination of truth values to A and B, right? And so those would be true true, true false, false true, and false false. Now, in the case where we have B repeated twice, we need to make sure that on each row of the truth table, we're consistent with the truth value that we assign to B, right? So in the first row, we said that B is true, so B will be true again. Second row is false, so it'll be false again. True again, false again. You need to be careful with that. You don't want to mess up these truth tables. These are things where if you're doing it on a test, you want to like double and triple check them because it's so easy to make a mistake. You don't want to do that. But now what we're going to do is we're going to complete our truth table, and we're doing this the exact same way we would do with as we did with our logical operators, right? So when we negate B on each row, we're going to get false, true, false, true. Okay, so now we have A or not B. So what will OR be? So we have T or F, that's true. T or T is true. F or F is false. F or T is true. Okay, so now what we have is everything here. So if that stuff, then this stuff. So let's compare. So if true, then true, true. If true, then false, that's false. False, then true is true. And true, then false is false. So the validity of our statement, here we have a completed truth table, and these are the truth values under the main operator. Now what we're going to do is look at another statement. And we're going to draw the truth table a little bit different. There's no right or wrong way to, option for doing this truth table. You can do it whichever way you like. More commonly, you'll see what I just did. This one you might like a little bit better for some organizational skills. So this is a long one we're going to have. We're going to have A or B, and if B, then A, then B. I believe that's what I wanted to do. Yes, okay. And so this is a little nice, like I said, for organization, because what we'll do is we'll just assign all of our truth values right here. So we'll say true, false, we will say true, 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 false, false, true, false, false, and now we have to go through the truth values. So true, 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 true. There we go. We just assigned our letters their values. True or true is true. True then true is true. True and true is true. True then true is true. There you go. True or false? Okay, true, false, false, true, false. True or false is true. False then true is true. True and true is true. True then false is false. If you're not understanding where I'm getting all these values from, by the way, you should really watch the last video I posted where we defined the logical operators using truth tables. I say you should, you need to. If you don't understand that, then you're not going to understand any of this. Alright, moving forward. So A is false, B is true, B is true, A is false, B is true. False or true is true. True then false is false. True or false is true. True then true is true. Now we're going to have A is false, B is false, B is false, A is false, B is false. False or false is false. False then false is true. True and false is false. False then false is true. And so there we go. We have our truth value. We completed the truth table and the truth values under our main operator. So that's how you do a truth table. It's a long, ugly, complicated process, but you got to be able to do it. So there you go. And now we're going to move on to our classifications of statements. So classifying statements. Classifying statements. There you go. That's legible. All right, so let's make a little table for this. So we're going to classify our statements based on the values under our main operator. So we'll say values under main operator. And then classification. We're going to draw out a nice little table to classify our statements. There you go. So if the values under the main operator are all true, this is why it's important to be able to identify the main operator. So if they are all true, then we say that that statement is a tautology, or logically true. Next, if the values under the main operator are all false, then we say that that statement is self-contradictory, or logically false. And I think that kind of makes sense, at least the name. If it's all false, then the statement always contradicts itself. It will always be false. And our third statement is contingent. Oh, contingent. So the values are at least one true and at least one false. Then our statement is contingent. It's contingent on the values of A and B, right? Because depending on A or B, this whole statement might be true or false. So let's look at an example of that. Let's go yellow, why don't we? So say we have the statements G then H, and G, then H. And let's assign truth values to G and H. Let's go, I don't know, let's go pink. Let's say true, 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 false, false, true, false, false. And now let's be consistent with everything. So we got true and true. G is true, H is false. G is false, H is true. Everything here is false. And now let's complete our truth table. So starting with the innermost operator, our horseshoe right here. True then true is true, true then false is false, false then true is true, and false then false is false. Now moving on to the next operator, the dot, for our conjunction. True and true is true, false and true is false, true and false is false, true and false is false. So now, moving on to our horseshoe, true then true is true, false then false is true, true then true is true, and false then false is true. So, if we look at our values under the main operator, right, so everything right here, they're all true. Looking at our table, all true means we have a tautology. So we would say that this statement is a tautology, or logically true. There's an example for you. And now what we can also do is compare statements based on the values under their main operators. And then we can compare these values under main operators. And then, I don't know, I'll say a comparison. And we're going to make another nice little table to define these things, to define our comparisons. So, let's make this big. There you go. Okay, so here's what we're going to say. If they are all true, again, then what we have are logically equivalent statements. Logically equivalent statement. Oh, sorry, I didn't mean to say all true. I meant to say all the same. They're all the same. We have logically equivalent statements. If they are all opposite, then we have contradictory statements. Contradictory statements. Now, we have two more. We want to look at when they're consistent or inconsistent. So when they're consistent, at least one line, the truth value is true. The truth values here. I'll say the truth values are both true. This is when we have consistent statements. And then we have inconsistent statements where on no line are both truth values, true. And it's here when we have inconsistent statements. Now, it's important when we are comparing two statements that their truth tables were constructed in the same fashion. So what do I mean by that? Well, let's go back to the top where we drew out two truth tables, right? When I was assigning values to our variables, right, and in this case we only had A and B, we did them in the same order, meaning the top row, A and B were both true. The second row, A is true, B is false. The third row, A is false and B is true. And the fourth row, A is false and B is false. So if you are comparing two statements, it is crucial that your truth tables align with each other. Otherwise, you're going to either make an incorrect classification or cause yourself a lot more trouble than you need to. Just always follow this order. It's way simpler. So now that we understand that, right, I want to do some examples of consistent or inconsistent statements, because I think logically equivalent makes sense, right? If the values under the main operators are all the same, so, they can we could have like true, false, and true, false, then, well, those were all the same, so they're logically equivalent. All opposite, say we had a tautology and a self-contradictory statement, so true, and false. Those are all opposite, so those would be two contradictory statements. Consistent and inconsistent, I think, maybe aren't so clear at first, so let's do a couple examples of that. Let's do a consistent statement first, so spoiler alert, these are going to be consistent. So if we have A or B, and then we have A and B, right? So we have two different statements. And let's choose a new color. Let's go pink, right? And so we want to assign A is true and B is true. Why do I keep making that mistake? Let's say A is true and B is false. Let's say A is false and B is true. And let's say A is false and B is false. So you see we're consistent with our assignment of truth values. And now let's just evaluate these. True or true is true. True or false is true. False or true is true. False or false is false. A and B, so true and true is true. True and false is false. False and true is false. False and false is false. Now in this case, right, we look at our main operators. Look at the truth values under the main operator right here. And we could see that on the first row, they're the same, true and true. On the second row, they're opposite. Third row, they're opposite. Fourth row, they're opposite. So they're not all the same. They are not all opposite. On the first row, both truth values are true. So we have the case where on at least one line, the truth values are both true. So this is a consistent statement. Now what we're going to do is we're going to look at an inconsistent statement. So let's just erase this entire thing. Need a better way to erase. And look at two inconsistent statements. So we're going to have K if and only if L. And then we're going to have K and not L. We are going to assign truth values and make sure we're consistent. True, 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 true. True, false, false, true, false, true, false, false, false. Okay. Looking at the left with the biconditional. So K if and only if L, true if and only if true is true, true false is false, false true is false, and false false is true. Now, on the second side, we have to evaluate the negation first. So not L, we're going to get false true, right? And now with our conjunction, true and false is false, true and true is true, false and false is false, false and true is false. So if we look at the truth values under our main operators, so right here and right here, first row is true, false, so opposite. Second row is false, true, opposite. Third row is false, false, same. Fourth row is true, false. So we don't have the case where they're all the same. We don't have the case where they're all opposite. There is no line where the truth values are both true. So we're left with our last case. On no line are both truth values true. So these statements are inconsistent. And that pretty much wraps up everything we're doing today. If you made it to this end of this video and you learned something, please consider subscribing as it would help me. But regardless, thank you for watching. I really appreciate it, and I hope you learned something.